Good morning to one and all. In the last class, we have discussed about the oxidation reaction. That one reaction is said to be Tollens reagent. By using Tollens reagent, aldehydes are said to be oxidizes to carboxylic acids, and that oxidizing agent is mild oxidizing agent. It oxidizes only aldehydes but not ketones. If you want to oxidize ketones, the type of ketones they are said to be alpha hydroxy ketones, they are oxidizes into carboxylic acids. Now, second type of oxidizing agent is said to be Felling's solution. The name of that test is Felling solution test. Comparing to Tollens and Felling solution, Tollens is said to be stronger than Felling. Tollens is said to be stronger than Felling solution. Hence, Felling solution is only for aldehydes. In case of aldehydes, it is only for acetaldehyde, formaldehyde, but not benzaldehyde. ಅದರ ಸಲುವಾಗಿ Felling's Tollens ಇವೆರಡರಲ್ಲಿ we are said to be, Tollens is said to be better oxidizing agent. What do you mean the term Felling solution? There are mixture of two solutions. One is Felling solution A and another is Felling solution B. Felling solution A is nothing but a clear solution of copper sulfate. It is blue in color, or it is known as oil of vitriol. It is known as oil of vitriol. Now this is Felling A is mixed with Felling solution B. What is that Felling solution B? It is an alkaline sodium potassium tartarate. Alkaline means base. Sodium potassium tartarate formula is said to be tartaric acid is COH, H and COOH. Instead of H I have taken here Na, sodium. Next here it is COH, H, COOH ಬಂದಾಗಿ K ತಗೊಂಡಿದೆ potassium. Sodium potassium tartarate. It is also known as Rochelli salt. This is Felling solution B. When you combine these two, what type of that reagent is taken in the reaction? It is only Cu2 plus ions are involved in oxidizing reaction. Okay, Cu plus is cupric form. If cupric form is converted into cuprous form, you can say that it oxidizes aldehydes to carboxylic acid. Okay, so general equation here I have given is RCHO. RCHO is an aldehyde. Now this complete form is said to be Felling solution reagent ಅಥವಾ Felling's reagent. ಎಲ್ಲ ಎರಡು ಕಂಬೈನ್ ಮಾಡಿ ನಾವು ಬರೀತಕ್ಕಂಥದ್ದೇನು Cu2 plus, that is Felling reagent, blue in color, and alkaline medium, that is 5OH is used. Now it is cupric oxide oxidizes aldehydes to carboxylic acid, whereas aldehyde it reduces cupric to cuprous. It reduces cupric to cuprous. Hence, this cuprous is in the form of cuprous oxide. It is reddish brown PPT. You have to identify that aldehyde is giving test to Felling solution. Okay. So like that you have to represent that Felling solution test by an aldehyde. The aldehyde you have to use is HCHO, CS3CHO. Their use definitely reddish brown PPT. If you use benzaldehyde, then there is no reaction. Benzaldehyde, no reaction. Hence, you can say that Tollens reagent that use test for benzaldehyde, formaldehyde, acetaldehyde, but Felling solution does not give test for benzaldehyde. Hence, this is said to be distinguished between Tollens and Felling solution. Is Felling solution it is gives only test for aldehydes, not for aromatic aldehydes. And tolerance reagent, it is giving test for aldehydes as well as benzaldehyde, but not ketones. But ketones, how? If they contain alpha hydroxy group, they are said to be undergoing oxidation. So like that, these are said to be two important reactions. What is the main use is said to be, this is practical purpose, confirmatory test. How do you distinguish between aldehydes and ketones using Tollens and Cummings solution? Important test. Now I will take another one oxidation reaction. That reaction is said to be oxidation of methyl ketone. Oxidation of methyl ketone, or well-known reaction. This is well-known reaction known as haloform reaction. Haloform reaction. What is the specialty of this reaction? If aldehydes and ketones, they must contain at least one methyl group. At least one methyl group attached to or linked to, attached to carbonyl carbon. What is the speciality or what is the condition of this reaction? Aldehydes or ketones, if they are showing haloform reaction, those must be containing one methyl group that is next to carbonyl carbon. Such type of aldehydes and ketones are only showing haloform reaction. How the reaction is represented? ಅಥವಾ ಈ ಪ್ರಾಡಕ್ಟ್ ಏನು ಬರ್ತಾವು ಇಷ್ಟ ಆದಮೇಲೆ definitely they are giving salts of corresponding carboxylic acids, as well as you can say that the haloform, that haloform formula is said to be CHEX3. ಏನು ಕೊಡತ್ತವೆ ಇಲ್ಲಿ? Aldehydes and ketones, they are said to be react with sodium hydroxide and halogen. If those are containing at least one methyl group, which aldehydes and ketones are containing at least one methyl group attached to the carbonyl carbon, react with sodium hydroxide and halogen, the products are said to be corresponding salts of, you can say that, carboxylic acids. And next is said to be haloform. Formula is CHX3. So I will write the equations. First one is said to be NaOH plus halogen is X2. Definitely it gives NaX plus NaOX. We use in the reaction sodium hypohalite. Its name is sodium hypohalite. Sodium hypohalite plus H2O. Okay. ಈಗ ನಮ್ಮ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಬೇಕಾಗಿದ್ದು NaOX. I will represent general equation. That is general equation. Aldehyde or ketone that is containing at least one methyl group. This is ketonic group, methyl group. Definitely it shows haloform reaction. Now NaOX, sodium hypohalite is used. Corresponding salt, sodium salt of carboxylic acid is formed, which is containing less carbon than the reactant. See here there are two carbon atoms, but here it is containing one carbon atom. Plus remaining is said to be CHX3. This is our product, that is haloform. how haloform is formed. Aldehydes or ketones, they are containing at least one methyl group attached to carbon, reacts with sodium hypohalide. How it forms? By the combination of sodium hydroxide and halogen. Now corresponding sodium salts of carboxylic acid and haloform is formed. Okay, for this you have to take various examples. I will give here the example as, you can take CH3CHO, one example. Another example is CH3, you can take, it is CH double bond C, CH3, and the next is C double bond O, ಆಮೇಲೆ CH3. ಇದಕ್ಕೆ ಏನು ಇಫೆಕ್ಟ್ ಆಗಂಗಿಲ್ಲ, the change is only in this case. How to try as general case. Okay, now how this haloform reaction mechanism is carried out, let us, I will try to represent that mechanism. Okay, so mechanism. Our product is RC, it must contain CS3, and there is a base that is OH minus. OH minus, it withdraws one of the hydrogen of this methyl group, forming EH2O, and remaining is RC double bond O, and next is this is carbon bonded electrons is on carbon minus, and this is H minus and H. Now I will take an example as iodine. X instead of X2 I will take iodine. That means I2, I bond I. ಇದನ್ನ suppose electrolytic fission ಆಯಿತು ಅಂತಂದ್ರೆ ಇದು ಮೈನಸ್ ಆಗ್ತೈತಿ, ಇದು ಪ್ಲಸ್ ಆಗ್ತೈತಿ. ಈ ಪ್ಲಸ್ ಯಾವ ಪೋರ್ಷನ್ಗೆ ಹೋಗ್ತೈತಿ? ಸಿ ಮೈನಸ್ ಹೋಗ್ತೈತಿ. ಅದಕ್ಕೆ ಆರ್ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಸಿ ಎಚ್ ಎಚ್ and R. Now again I will use that base NaOH. This OH is withdraws one proton, forming H2O. Remaining is RC double bond O and C I and this is H. Now I will take another, sorry, what is this? Minus sign. I will take another I here. Again the same process is carried out. Now it becomes RC double bond O C H, and this I is on this position, that is I and I. Now I will continue this case. RC double bond O C, that is H I. Again OH minus is there. Now what happens here? Definitely it withdraws electrons, but these electrons are towards this carbon. Now it becomes minus H2O RC double bond O. Now it is C double bond C. It becomes H and H. Okay, sorry, I and I. Okay, now what happens here? Again there is I minus I. That means I bond I, as it is same formula is taking place. Now these electrons is on this carbon, and this is said to be shifted to this carbon minus, or you can take here it is on this carbon as it is. I will represent RC double bond OC minus I. Now there is first you have to represent here OH. Before that you have to represent here it is OH, or simply the change you have to take that as H double bond. Okay, this is O minus, it becomes R C O minus double bond C I and I. The shifting of this side and this side, now it becomes double bond, and this is minus I. Next is said to be, you can take it as in this case again I minus I, it becomes RC double bond O, and this is I CI3, you have to take it is CI3. Okay, now it is nothing but splitting, and remaining is said to be R C O minus single bond C I3 OH minus, that involved is said to be this is carrying plus sign. OH minus is on this position, it becomes RC O minus and OH, and this is CI3. Now there is again shifting of these electrons, and these electrons are on carbon, and this OH is to this position, becomes RC double bond O. Now it is OH plus CI3 minus, bonded electrons on carbon, that is CI3. Next is H plus OH minus. This is definitely carboxylic acid, remains RCOOH plus. This H plus is on CI3, hence it is CHI3. This is said to be iodophore. Just you observe, it is enough. Yellow PPT. Okay, so once again I will shortly represent that mechanism. There is aldehyde, it is containing methyl group. Loss of proton is taking place simultaneously, and in that case addition of iodide plus I plus is added or substituted simultaneously. Loss of proton and substitution of iodide. But at the case what happens, if there is only one hydrogen on the carbon, there is shifting of this carbon hydrogen bond to carbon carbon bond. Now it becomes RC double bond O. There is a instability of bond. Now it becomes bonded R shifts, and it becomes RCO minus E double bond ಈ ಕಡೆ ಶಿಫ್ಟ್ ಆಗಿರ್ತಾವು. ಅವಾಗ ಏನಾಗ್ತೈತಿ ಅಂತಂದ್ರೆ ಮತ್ತೆ as it is, there is addition of iodine is taking place, I plus is taking place, and all the steps are continued until carboxylic acid is formed, and there is Ci3 minus. Lastly, it undergoes hydrolysis and giving iodophore, that is said to be yellow color PPT. Okay, such type mechanisms are not asked, but how they are taking place, the reactions are taking place, that is important. Therefore you have to follow, just observe, not for practice. Okay, yes.